Current network interface configuration. To see the network configuration, you can use commands such as ifconfig, iwconfig, iwlist, and route. Try the ifconfig by itself. See the IP version 4 and IP version 6 addresses of the ETH0 network card. If there's more than one network card, as is shown here, you can zero in on that card with the ifconfig etho, or the name of the network card you want to focus on. You also need to know the current wireless configuration of a system. The iwconfig command looks at all network devices and finds detected wireless systems. In this case, my ETH0 card is a wireless card. It has information such as the network type, in this case 802.11g, the network identifier, also known as the ESSID, short for the Extended Service Set Identifier, in this case Randy Nancy. It also identifies the hardware address of the access point. In this case, it starts with 00:14 and so on. The speed or bit rate, 36 megabits per second. The link quality, 84/100, and more. If you need to connect to a different access point, the iwlist command can help. We use it with the wireless device to scan for available networks. If there were more than one wireless network available with the same name, say default, I could connect to that network using the hardware address. Next, the route N command specifies the current routing table. I like the -N switch as it avoids having to search through etc/hosts or DNS servers for actual destinations. The last line in the output shows the route to the default address of 0.0.0.0. And to get to the default address, information is routed through 192.168.0.1, which is therefore the gateway address. Next, the etc resolve.conf configuration file includes IP addresses of governing DNS servers. If information is not available in that database, it might be available, especially if the system's on a local network, in the etc/host configuration file. All of this can be confirmed with the Network Settings tool, which you can open in a GUI with the network admin command. Let's find the GUI and run the network admin command. That opens the Network Settings tool, which I can unlock, and since my account has administrative privileges, I use my account. I enter my password. I type in authenticate. I typed in the wrong password, and there it is. I have full access to the Network Settings tool. Let's look at the properties of a wired connection. I can specify a static IP address. I can set it to get its IP addressing information from a local DHCP server. But I'll skip that. I click the General tab and I see the host name and the domain name of the local system. I click the DNS tab and I see the information that was in the etc/resolve.conf configuration file. These are the IP addresses of the DNS servers I use. The host tab is a complete reflection of what you would find in the etc/host configuration file. Now let's look at something else. The UCP curriculum suggests that you need to know how to configure a telephone modem using the graphical tool. Well, what a coincidence. That graphical tool is the network settings tool. So let's go back into the Connections tab. And there's our telephone modem. It's the point-to-point connection. I select that connection. I enable it. The connection type can be a serial modem, which is typically a hardware modem. It can be a USB modem, or in some cases it can even be a Windows software modem, but details of such is beyond the scope of the UCP curriculum. To configure this modem, I enter the phone number required for the connection. If I'm someplace like an office or a hotel, there's typically a dial prefix to access the standard telephone system. I enter account data. And then I select the modem tab. At which point I have to specify a modem device file. Several are available when I click the drop-down text box, and a properly detected modem is typically linked to the dev modem file. There are two choices for dial type: touch-tone dialing, which will be used in most cases, or if you're using a rotary telephone, you would use pulse dialing. The volume, especially if you have a hardware modem, controls the speaker just on the modem. The options are fairly straightforward as well. If the modem is the default route to outside networks such as the internet, you'd select this option. If you want the dial-up ISP to provide DNS server addresses, you'd select this option. It would supersede any information you'd have in your etc/resolve.conf configuration file. If your telephone connection is cut for some reason, say somebody accidentally picked up the telephone in another room, you yell at them to put it down, and this option would retry the connection. Configure a DHCP client. The UCP curriculum includes a reference to the etc/dhclient.conf configuration file. That file has been superseded by the etc/dhcp3/dhclient.conf configuration file. Even though the directives are active, as shown here, they're not put into effect unless a network card is configured to use DHCP. That's possible in the etc/network/interfaces configuration file. If it's not there, you can set it up directly with the dhclient command. Of course, DHCP clients on a network card can be configured through GUI tools such as the network settings tool, which you can open with the network-admin command. As you can see, there are several directives just in the default version of this file. The request directive requests the IP address from the DHCP server. The subnet mask, also known as the network mask, is also requested. when the subnet mask is coupled with the IP address that defines the network, as well as the possible IP addresses of other systems on the local network. The broadcast address specifies the IP address, which sends messages to all IP addresses on the local network. The time offset directive specifies the difference in time relative to UTC. That's a foreign acronym, functionally equivalent to Greenwich Mean Time, or if you prefer, U.S. Military Zulu Time. The routers directive requests the IP address of routers, also known as gateways to outside networks. The domain name directive looks for a domain name for the local network. It would return something like example.com. The domain name servers directive requests the IP address of DNS servers as configured on the DHCP server. The hostname directive looks to the DHCP server to assign a hostname, but if the hostname is fixed during the installation process, you may want to delete this hostname directive from the DHClient configuration file. Finally, the NTP servers directive looks for IP addresses of available network time protocol servers. If you want to configure access to an NTP server, that server should either be on a local network or at least someplace close to the local network to minimize the effect of transmission delays. Network configuration files. There are several network configuration files. I've alluded to a few in another video. We'll look at them more directly here. First, there are some basic configuration files, such as etc/hosts, which contains a database of host names and IP addresses. You can add the host names and IP addresses of your choice to this file, but that practice is generally discouraged for Internet host names, as there are too many of them for any single text file. So most systems rely on domain name service servers, normally configured in the etc/resolve.conf configuration file, with directives such as name server followed by the IP address of the DNS server. But what if there's a conflict? The etc/host.conf and etc/nsswitch.conf configuration files determine which database is read first. Normally, as local hosts are configured in etc/hosts, that file should be considered first. And that order is reflected in etc/host.conf with the order host, bind directive. And it's also set up in etc/nsswitch.conf with the host file's DNS directive. There are a number of files in the etc/network directory. Most relate to starting or stopping installed network services, when a network card is activated or deactivated. Perhaps the key file in the etc/network directory is interfaces. Let's examine this file in a bit more detail. The first couple of lines automatically activates the loopback interface. The auto LO automatically activates the loopback device. The iFace LO specifies that same loopback device. The iNet directive is associated with IP version 4 addressing. And the loopback directive specifies the loopback address 127.0.0 8.0.0.1. The next set of directives are associated with a dynamically configured network card. ETH-O in this case. The auto ETH-O directive activates this card during the boot process when networking is started. The iFace ETH0 innet DHCP directive specifies IP version 4 addressing, getting information from a DHCP server for interface ETH0. If you prefer static addressing, you'll have to add more detailed information. For example, if I were to replace the iFace ETH0 innet DHCP with the stuff and comments that follow afterwards, I could specify the static address for a specific wireless network. In other words, I configure a managed wireless network connected to a regular access point on a specified IP address, network mask or netmask for short, a gateway address which is added to the route, and a certain wireless ESSID or network name. Them's the basics of Linux network configuration files. Network management from the command line. There are several commands which can help you configure network cards. In this video, we'll discuss the ifconfig, iwconfig, iwlist, route, ifup, ifdown, as well as network manager's nmtool command. First, there's the ifconfig command. Run by itself, it displays the current status of all configured network cards. When run with the name of the interface, in this case ETH0, you can focus in on a specific network card. And with administrative privileges, you can specify a new IP address, and if you prefer, a different network mask. Next, there are the wireless network configuration commands, iwconfig and iwlist. The iwconfig command, by itself, is similar to the ifconfig command as it checks the wireless characteristics of all configured network cards. You can use it to change the connected network access point, specifically the ESSID, which is short for the Extended Service Set Identifier. If my wireless card is ETH0, the command shown here, sudo iwconfig ETH0 ESSID, Nancy Randy, changes the network to the Nancy Randy network. In a number of public locations, I run the iwconfig command and I see a bunch of wireless networks. And what happens, say, two of them have the same name, such as default? Then I could connect to the preferred network by specifying the wireless network hardware address. But how do you find that hardware address? That, as well as the ESSID, is available courtesy of the iwlist command, as shown here. Next, there's the route command. When run by itself, it shows default routes. I prefer to run it with the N switch, as that ensures that the routes are taken in numeric format. I can delete a default route, but I don't have one yet, so let's go to add a default route. I add a default route through my gateway system, which is available at address 192.168.0.1. I confirm the changes, and I see I have a new gateway. I can reverse the process by deleting the default route with the following command. I confirm the result, and my default route is now deleted. Now let's examine the IF-up and IF-down commands. Well, since networking is activated on this system, let's first deactivate networking. It requires administrative privileges. The AV switch deactivates all network interfaces in verbose mode. Watch as it first deactivates the loopback interface, runs several scripts in the etc/network directory, deactivates the active Ethernet interface, and deletes the default route. Let's reverse the process and reactivate the network. Let's scroll back a bit. The command activated the loopback interface, assigned the loopback address of 127.0.0.1. It also runs several scripts in the etc/network directory, activates the first Ethernet interface with a specific network mask and broadcast address, courtesy of what's available in the etc/network/interfaces file. And it finally adds a default route with a given gateway address. Finally, there are the commands associated with the Network Manager. It allows automatic searches and connections. It also supports whatever preferences you set from the GUI, but the GUI part of the Network Manager is trivial. Just right-click on the network icon. In contrast, the Network Manager package includes the nmtool command, which can track the status of all local network devices. Properly configured, it can also display the driver, the hardware address, and wireless capabilities of the card if so configured.